Welcome to Maths with EJD. In this video, I solve another structured problem in two parts. The first one is if the class marks in a frequency distribution of the time spent receiving lectures in a course in minutes are 130, 139, 148, 157, 166, 175, and 184. Find the class interval, class boundaries, and class limits. To be very sure, the way you are taught this kind of thing in class really matters because my interpretation may be probably different from the approach in class. For instance, I believe that class limit should come before class boundaries. So, you want to be sure you follow however you're taught in class. Then B, want to calculate the mean deviation of the following scores in a course: 61, 55, 56, 78, 61, 55, 37, 47, 55, 78, 25, 35, 95, 77, 78, 55, 47, 55, and 95. So let's go. Okay, we have the class marks in that case. So we got say given. Okay, well, let me start on this note. Given class marks 130 incremented by 9, 139 incremented by 9, 148 incremented by 9, 157, then 166, 175, and 184. So given this now, the first thing we want to find is the class interval. So we say 1 to find the class interval. Okay, just like I said the other in the previous situation, imagine that like when you have the problem of 3, 7, frequency 3, 8, 8, 12, maybe frequency is also 3, and then you now have, now this is just by the way, right? You have 13 to 17. So you know the class mark, this is X big. The class mark, which is small x, if you like, is 3 plus 7, 10 divided by 2, that's 5. Then this is 15, and this is 20, and it goes on like that. So that means that each of this is just like this 5, 15, and 20 now. So if you want to get the class interval normally would be, 3 minus 7 minus 3, which is 4. So it means that the class mark would actually be the different, the in class interval, you're going to derive that from, what's the first question again? Let me see. Class interval size, yes. So the class interval size for me should actually be like so if this is 4, then that means it's 15, 15 minus, this thing is increasing by 5. So sorry, this is 10. Sorry, this is 10, this is 15. So this is increasing by 5. So you can find the difference between this and subtract 1 from it. That will give you the class interval size. That is what I believe. But be careful to do it exactly the way you're taught in class. So in my case now, I would rather believe that if this is x1, x2, x3, x4, x5, x6, and x7, if that is the case now, so I can say that, so we are looking for the class interval size, right? Find the class interval size. So I can say that the class interval size is equal to xn plus 1 minus xn minus 1. So that means you can have, say, x2 minus x1 minus 1. Or if you like, it's the same thing as pick any random x, maybe x7 minus x6 minus 1. Anyhow, it's the same. So let's stick with anyone. Let's say x7 minus x6. It's exactly, we know the difference is already 9. So 184 minus 175 minus 175 minus 1. So that is 9. Make sure that is 8, right? That's 8. So we can say, therefore, the class interval size is 8. The class interval size is 8. So I speculate that it's possible that in some situation they'll just stop at 184 minus 175 and the answer is 9. But based on the logic I used the other time, except if you now also want to see class interval instead of 7 minus 3, you want to see it as 3, as counting from 3 to 7, 3, 4, 5, 6, 7, you know. So it all depends on how you see that. But by my interpretation, right, by what we've been doing so far, I'd rather subtract 1 from it so that the class interval size is 8. So be careful to do exactly what you're taught in class. So the next thing will be, though we are told to find the class limits last, but I think that should actually come second normally. So I'll just go to 3 first. So to find the class limits, again, from this example of 3 to 7, right? If the class mark is 5, so the class limit is actually this 4 now, that is the difference. If you divide that by 2, 4 divided by 2, that's 2. So subtract that 2 from 5, you get 3. Then add that 2 to 5, you get 7. So it means that if the class interval size is 8, so uh if the class, okay, let me put it this way. If the class interval size is 8, you know, the class limits, the class limits can be obtained by subtracting by subtracting and adding by subtracting and adding uh 8 over 2 equals 4 to each class mark, okay. So that means we have all the class marks 130 to 184, right? So it means if you have 130, you have 139, you have 140, 130, 139, you have 140, what are we doing? 130, 139, yeah, 148, 148, 157, 164, 173, and 182. Is that the idea? Is that what we have? Okay. Uh, okay, this should be 166 actually. This is 166, 175, 184. So if that is what we have, right? So we need to subtract and add 4 to each value. Subtract and add 4 to each. So we have subtract 4, add 4 to each like that. So this is more like 130 minus 4 is 126 plus 4 is 134. Then here we have 139 minus 4, that's 135. Here it's 143. So you can see, you can just keep adding 9 to those ones too, and you keep going. 134 plus 9 is 143. So you can definitely do that once you get that pattern. So here, this is just me. 135 times, 135 plus 9, that's 144, 153, 162, and 171. I believe 171. And here, same. You have 152. You have 161. Then you have 170. And then you have 179. Yeah, 179. So we can say the class limits. So we can say, therefore, the class limits given as the collection of lower comes first, the collection of lower limits and upper limits, such that you have all that. You have 126, 134, that's the first one. Then 135, 143, 135, 143. Next is 144, 144, 152. Is that correct? 144, 152, yeah. Then 153, 161, 153, 161. Then we have 162, 170. Then we have 171, 179. Yeah, so those are the class limits. That's what I think it should be, but be careful to follow what your thoughts in your own specific situation. So the interpretation of the teacher teaching really matters. So be careful. So then I can go back to class boundaries now because class boundaries depend on class intervals. So three now, I say to find the class boundaries, to find the class boundaries. So from what we already have, right? 126, 134. Okay. Then we have 135 and then 143. Then we have 142. I mean 144, 144, 152. And this is 153, 161. Then we have 160, 170, 162, 170. These are the class limits because this it's going to determine the class boundaries 171 to 179. So look at this now. To get the class boundaries, this is how it goes. You add these two and you divide by two. So the class boundary, the upper class boundary is going to be like 134 plus 135 divided by 2, which is 134.5. Okay, that's the upper class boundary here. So, and the upper class boundary here is going to be the lower class boundary in this place. That'll be 134.5, against so 143 and 144. That'll be 143.5. Okay. Of course, this one it's like you're subtracting 0.5 from this. So this will be 125.5 against 134.5 up there. Then of course you are going to see that 999 thing happening again. So if you add 9 to this, you get 143.5, 152.5. So it's more like add 0.5 to this and subtract 0.5 from this. Okay, that's another way to look at it. So to find the class boundary, right, subtract 0.5 from the lower limit and add 0.5 to the upper limit. In fact, let me write that down. So an approach to finding class boundaries, which tallies with other approaches, which tallies with other approaches, is to subtract 0.5, subtract 0.5 from the lower limit, and add 0.5 to the upper limit, basically. And if you do that, right, since you already have the limit, so for the boundaries again, so you have 125, we have you have 125.5. That is 126 minus 0.5, that's 125.5. 135 plus 0.5, that's 134.5. That's for the first one. And then we go on like that. So this would be 134.5, 143.5. And we have, then you can now see even the 99 thing will start happening now. 9, that's 143.5 lower. So the upper boundary here is the lower boundary in the next class. So here, the next one will be 152.5. So you have that 152.5 here now. And then 161.5. So that's the lower boundary for the next one. That's 161.5, 170.5. Then next you have 170.5, and then this is 179.5. So these are the class boundaries. The class boundaries. And with that, we come to the end of the first part of the question. That's A now. So, I mean, I know be careful, follow what you're taught in class. I know that it's just be a bit of difference or something, so but be careful of that. So let's talk about the mean deviation of the following scores. So, so B now, to calculate mean deviation, calculate mean deviation. Okay. As the name implies, right? You need the average of all the deviations. So basically, if you like, you want to call that, okay, let's just call it the full name. Mean deviation is actually the of all, sum of the absolute value of all deviations divided by sum of the frequency, or better still, since we have it on groups, so we can say n. That's the number of numbers you have, so to speak. I think it's always good to make this thing in a table format to make life easy. Though we have a lot, we have, I think we have like 19 numbers here. So let's see how we can do that. Say we can also, we have X, right? We have X, okay. Apart from that X, we need X bar for sure. So let's say we have X now, which is 61, 55, 56, 78, um, 61. Or is this table going to be worth it? I don't know. Okay, let's do it this way. Since it's pretty long, we could as well not bother about table. So, but we want to find mean deviation. Um, okay. I mean, this is the same thing as summation of xi minus x bar divided by n. So x bar is the mean. So, and we know x bar is, mm, say, summation of x over n. That is, add up all the numbers. So you have 61 plus 55 plus 56 plus 78 plus 61 plus 55 plus 37 plus 47 plus 55 plus 78 plus 25 plus 35 plus 95 plus 77 plus 78 plus 55 plus 47 plus 55 plus 95. All of this divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19 in all. So we have to do this, and it requires carefulness because it looks like it's a lot. So let's go and add up these numbers now. Okay. Mm, okay, 61 plus 55 plus 56 plus 78 plus 61 plus 55 plus 37 plus 47 plus 55 plus 78 plus 25 plus 35 plus 95 plus 77 plus 78 plus 55 plus 47 plus 47 plus 55 plus 95. Then all that now. is 1145. So that is 1145 divided by 19. So that should be approximately 1145 divided by 19. So that's 60.26. That's the mean. So for the mean deviation now, so what do we do? So let's say we need, I think I'll go straight for the next one now. So we now need summation of absolute value of D, which is summation of absolute value of xi rather, minus x bar. So it means you are subtracting each one from x like that. So mean, so it means we have to say 61. I guess I'm just going to do everything at once to avoid stress. 61 minus, can we do this? Okay, let me see. Can we do the bar? Okay, I mean, let's take it one after the other. So we can see the number. So we have first one is 61. 61 minus 60.26. 61 minus 60.26. That's 0.74. 0.74 plus, absolute value means that we don't care about the minus. So even if there's a minus, we drop it. That's what absolute value means. So 61 settled. Okay, I should have changed the marker here, but it's okay. Let me just continue with that. Then the next one is 55 minus 60.26. 55 minus 60.26 is minus 5.26. But we don't care about the minus, so we just drop it and we have 5.26 plus 56 minus that is 4.26. 78 minus that is 17.74. Then 61 again. I think 61 is 0.74 again. 0.74. 55 is 5.26. Then 37 now. 37 minus that, 37. That is 23. It's actually minus 23.26, but we don't care about the minus because it's absolute value we are concerned with. Then the next one is 47. 47, that's minus 13.26, but that's just 13.26. 55 again is 5.26. 78. Okay, 78 is 17.74. Then we have 25. 25, 35.26. 35 is 25.26. Then we have 95. That's 34.74. That's 95. Next is 77. 77 is 16.74. 78 should be 17.74. 55 again. That's 5.26. 47, 13.26. 55, 5.26, I believe. Minus 5.26, but we'll just take 5.26. Then lastly, 95 again. That's 34.74. 34.74. So we can now divide all this again by 19. That's the okay. Okay. Let's not divide by 19 first. Let's just get the answer. So this is 34.74. So we can add all of that together carefully. Very important, carefully. 0.74 plus 5.26. I wrote 5.36 there, so we have to be careful. 0.374 plus 5.26 plus 4.26 plus 17.74 plus 0.74 plus 5.26 plus 23.26 plus 13.26 plus 5.26 plus 17.74 plus 35.26 plus 25.26 plus 34.74 plus 16.74 plus 17.74 plus 5.26 plus 13.26 plus 5.26 5.26 plus 34.74 again. Okay, we have to check again. 0.74, 5.26, 4.26, 17.74, 0.74, 5.26, 23.26, 13.26, 5.26, 17.74, 35.26, 25.26, 34.74, 16.74, 17.74, 5.26, 13.26, 5.26, and 37, 34.74. Okay. Um, why? We need the answer. Okay, finally, we have that to be 281.78. So we can now say, therefore, mean deviation is equal to summation of d, absolute value of d over n. So that is 281.78 divided by 19. So that's approximately 281.78, 281.78 divided by 19. And that is 14 point something, I believe. 14.83. That's approximately 14.83. So we can say, therefore, the mean deviation is 14.83. So with that, we come to the end of this particular question, bordering on class marks and mean deviation. If you have not subscribed to this channel, you want to do that and hit the notification bell so you can always get alerted when a new video is released. Don't forget to comment. Tell me if you want me to treat a topic or solve a problem, and also share so that more and more people can actually have um they can have access to this great learning going on here like that. All right. So see you next time. Bye.